Welcome to Shift Happens, the podcast where we talk about energy, tech, leadership, and large scale projects, where sometimes, let's be honest, not everything goes according to plan. My name is Manuel.
And my name is Dirk. And together we both talk about topics that we regard as interesting, challenging in the wide world of energy developments.
So, today we're going to talk about carbon capture and storage, short CCS, and carbon capture and utilization, short CCU. We're going to talk about the technologies, what they are, why they are so important currently, and what they are used for. But I think it's, again, important to start with the very basics. So CCS, carbon capture and storage, is the capturing of CO2 at the source. The source can be, for example, like a refinery. Then you compress the CO2, you transport it, and then you store it in geological formations.
Yeah. And these geological formations are typically depleted gas and oil reservoirs, so reservoirs which are not producible anymore. And additionally also what's called saline aquifers, so deep salty groundwater layers where you can pump the CO2 into and where you can store it actually also for quite a long time in a safe manner.
Exactly. And on the other side, CCU, as the name already says, carbon capture and utilization, is the same process as for CCS, but instead of storing the CO2 in an underground formation, you utilize it to produce or modify processes like in the chemical industry. You can produce synthetic fuels. It's used for concrete curing, but there are also very exotic ways of producing CO2, like CO2 vodka, for example.
Yes, yeah, you can Google it. It exists. But I guess the main effort goes to synthetic fuels or to the concrete story there.
So both processes aim to reduce atmospheric emissions, one by storing it away and one by utilizing and repurposing it. It's important to understand that only CCS is reducing CO2 permanently because it stores it away, whereas CCU is more utilizing and repurposing it. And if you, for example, generate synthetic fuels with it, you actually lock it in the fuel, but once you burn the synthetic fuel again, you're actually releasing the CO2 again. So it's not a permanent reduction of CO2 on the long run.
Yeah. Okay, so when we talk about emissions, we talk about greenhouse gas emissions, CO2. We're all aware that there's a lot of policy around in the world, specifically in Europe, targeting dates where we reach a point where we have 0% of CO2 emissions, artificial CO2 emissions that basically are influencing the development of the temperature curves on the Earth. So that is the policy level. The targets are usually between 2035, 2040, 2050. Regions, cities, countries are having these target dates. So that is what the whole, from the policy down to actually how these solutions are implemented, where everybody is sort of deemed to work on. And specifically industries which have CO2 emissions which are really hard to avoid, like cement, steel, kind of incineration processes, they need to have solutions for capturing it, transporting it, and then ultimately storing it, as we said, in underground solutions.
Yes, and I think just to understand, I mean, there's a lot of effort in different industries and different areas to reduce CO2 emissions in their processes and how they power the factories and stuff like that. But with these hard to avoid industries, they face a challenge since let's take the cement example. Just by electrifying a cement factory, for example, so all the power generation is more or less electrified. That doesn't get rid of all the CO2 then, because CO2 is already produced in the chemical process of generating cement with the current processes. So just by making cement, you're producing CO2. So it's really difficult to avoid this CO2 if we stay with the same processes as we have. Now, there is, of course, technological innovation going on in this area. So there are currently people working on cement that can be produced with reduced or with no CO2 production at all. But this is in a very early phase. It's in a very technological state, I would say. So this is definitely something we should look at, but it's not something that we can use or utilize right now to satisfy the demand of cement that is needed for construction of roads or buildings and stuff like that. So for these kind of industries, we need to find a solution on how we can reduce the CO2 emissions. And this is where CCU or CCS plays in.
Yeah. So specifically for these amounts, we talk about CCS. And there again, as stated, it's the right capture technology and then transport and storage and finding the best possible solutions for that in the end. Because there is not only the technical level and the costs that we will talk about that we'll have to overcome, but also how the public is basically accepting the solutions in the end, and the general understanding of the public that, yeah, we are not looking forward to just utilize things or to continue burning fossil fuels until eternity. But there are solutions that need to be implemented in order to keep the industry running. Yeah. We will talk about it, I guess, anyway, in the end, a little bit more in detail.
And if we think about CCS, I think there are already some projects existing, actually quite old ones. I think the oldest one I'm at least aware is in Norway in Europe, which is the Sleipner project. I think it started injection in 1996 or something, so
Exactly.
it's quite a old project. So it's a proven technology in a way. Nonetheless, the storage capacities that are currently available are way beyond what we would need. Just as a reference, to my knowledge, is we have currently globally around 50 million tons of CO2 storage capacity available, which is on a global scale. And just in Germany alone, because we are currently sitting in Germany, I think Germany is producing around 650 million tons a year of CO2 emissions.
Yeah.
Now, this is quite a big gap we need to bridge. And I think industries and countries are currently looking into building more storage capacity, particularly Norway, Denmark, the Netherlands are looking into this because offshore storage capacity is quite large, so to say. So we're gonna ramp up this capacity hopefully quite soon. But we can see already there's quite a big gap between what is produced and what can be stored. So I think that's gonna be quite a tough challenge to really come up with a proper solution in time.
Yeah. We discussed this, I think, in the past very often. The solutions, the old solutions which are already running, they were sort of driven by certain developments in the countries itself. In Norway, it was sort of a tax on CO2 that was implemented. And at the time, the state oil company, still called Statoil, nowadays Equinor, they started the Sleipner project. This is, I think, like 1 million tons per year that they're able to
Hmm.
store there. If you look at the bigger scale, the scaling is, as usual, is the biggest challenge in everything that we're looking at in these discussions. EU targets for 2030 are these 50 million, actually, 50 million tons per year to inject. That has been, for example, then distributed to the existing oil and gas operators in Europe, which have quite a struggle with it to make this ready in a very short amount of time. So time is also a big factor in these solutions. It deals not only with that there somebody says this is the policy you should provide the solution until this date. There might be penalties ultimately connected to it, but it's also in the end the license to operate of a company if they emit beyond a certain point, and this is not actually allowed anymore. So there will be many discussions in the next decade on how to find the right solution. CCS is so probably one of the most important solutions that we have in order to keep the industry running with the processes and the products that the society actually needs.
Yeah, to me, it's like I think CCS, as you just said, is a very important element to really be able to achieve these ambitions and targets. I even call it ambitions because I think to my understanding, it's quite unreasonable to expect that these kind of industries will be able or will be CO2 neutral by 2030 or 2040 without the CCS technology. It's just not going to work because we need to keep them running in a way. We need these are elements and resources we need on a daily basis, like concrete and chemicals. They are needed everywhere, and just to stop them is not an option. So I think CCS is really an important element, and we really need to pick up the pace on that area to achieve the ambitions or targets, as
Yeah.
we call it. Now, let's be honest. As already mentioned, CCS is already proven technologically. So, with projects like the Sleipner project in Norway, as already mentioned, CCS has been injected since 1996. There are other projects like the Northern Lights projects in Norway, or the Porthos projects in the Netherlands, and the Aramis projects, for example. These are currently in the planning. Porthos is already in the execution phase, so to say. So the concept is proven technologically. So what is hindering us on moving forward?
Yeah, you mentioned these projects. These are necessary analogs, yeah, that need to show that it actually works. Norway is already working on it since quite a long time. For all the others, of course, the economics and acceptance are coming into focus. Yeah? So the costs to capture CO₂ at any given site with specific technology, that is around $50 to $100 per ton at least. Yeah.
Mm.
And then if you add transport and the storage to it, you sum it up then usually towards at least $100 to $150 per ton. But the price, depending on local circumstances and transportation distances, even go up to $300 per ton. Yeah,
Wow.
this is not unrealistic, because also all the prices that you see published that we're talking about are often prices which are from the planning stages of the projects, which might not be exactly the ones that will come to the table when you make your final investment decisions. Yeah. So there is a significant amount of money to be spent to build infrastructure for CCS.
hmm Yeah, and with these high prices, I mean, that's quite a big number for getting rid of your CO2 as an emittent. So I think that's quite an unrealistic price for like an open market situation. It's quite expensive. So I think there needs to be some kind of yeah, either substitutions, or even like a laws, like mandatory requirements to get rid of the CO2, which is actually currently happening. So the main driver is these targets that the emittents are yeah, given by the government. So they need to be CO2 neutral by 2030, for example. So they need to find ways to get rid of their CO2. And CCS is one of the solutions, but it has to be for an acceptable price also, because else it's not going to work out for them.
Yeah. So CCS is a very complex, holistic activity that needs to be brought on base. So it's policy, it's economics, it's all kinds of factors that you need to look at when you think about generating a market. Yeah? The market, as we said, is just still developing, and into this developing field where you do not even have a finally fixed price, you need to build infrastructure into it. You need to have the right risk share between industry and the governments in order to make it work if you have the timeline in your mind. Yeah, it's not something that just is developing like any kind of market. It has a time pressure on it, and it really needs the optimal incentives actually to go forward.
Yeah, exactly. And it's a very complex project, as you just said. It's not just technological, it's societal. There needs to be public acceptance. The whole CO2 market needs to be established. It's currently in the very early phases. It's not really there yet. And there are also other things that need to be considered. So it's a value chain of different industries and handovers of the CO2. So who is taking the responsibility of the CO2? Who is taking the risk over if something happens? This goes down to who is taking the liability of once the CO2 is stored in the storage. You need to monitor it and make sure that there is no leakage or no CO2 coming out of the storage. So who is taking care of this and monitors the reservoir for 30 or even almost 100 years? Who is going to do that? And these are things that need to be clarified to make the technology really scalable and economically workable.
Yeah. So coming to CCU for a moment, that's supposed to be better, isn't it? So
Well, it sounds like.
we transform the CO₂ into plastics, synthetic fuels, or make building materials out of it.
Yeah, the problem, as I already mentioned, most CCU solutions are not permanent solutions. It's when you generate a synthetic fuel out of CO2, then you just shifting the problem to a later point in time, because once you burn the synthetic fuel, you release the CO2 again. Now, this is what we call circular solutions. It's not a carbon negative or a permanent solution. It's more a circular solution. Now, it has its uses for industries like aviation and stuff like that. So it's an important element, but it's really important to understand that most of these solutions are not permanent solutions. It's more circular solutions, shifting the problem from one way to another way, so
Yeah.
to say.
But if you produce um, these products with the maximum utilization of renewable energies, you actually can minimize the usage of fossil fuels significantly by turning. I guess this is also the driver that the development there is actually also quite active in these developments. Um, but then still, you said aviation is one of the key application areas for synthetic fuels then in the future because they cannot really replace it by anything else. But how would that then go further? When we're looking at scale, yeah, on amounts that actually need to be produced.
Yeah, I mean, again, it's scaling and economics is one of the biggest challenges. Most of these things are in a more early phase technological stage. There are also some niche wins. Just to mention it, there is something like what we call cement curing, so where CO2 is permanently locked into cement. So this would be a permanent solution. So there are a lot of technologies going on. It's as I said. It's a lot of innovation, and there's a good reason for why we want to do it. But all of these, or the majority of these solutions are in a very early phase. So again, the question is it economic on a large scale? Can we scale it, and what's the price?
Yeah,
And this is the main challenge. Same with CCS, but also with CCU.
yeah.
Okay, so now let's talk a little bit about what is holding us back in general for all of these solutions.
Well, we touched on quite a lot of topics already on the way here. So I think we can highlight three main domains. So we talked about the prices. Economics, CCS is expensive and needs significant investments in infrastructure. That is then the second point, infrastructure and technology. Um, I think the emitters, they find solutions in their factories or whatever to make the capture working. But the biggest challenge is actually building the transportation network to bring it to the storage sites, which are at the moment mostly offshore, so usually pretty far away from the actual emitters. And on top of that, technological challenges. It's not always the same CO2 that is emitted. Well, essentially the CO2 is the CO2, but it comes with kind of impurities
Hmm.
and they are process related. In some processes, you have more even oxygen and other aggressive gases in tiny amounts, but over a long period of time in pipeline networks, they have a significant effect on corrosion. Yeah? And these are also price drivers if you have to mitigate sort of non-optimal CO2 streams.
Hmm.
Yeah, that's the thing. And the last big point is policies and regulations. The EU is giving on a high level sort of targets, fairly big targets, but there's in the countries, some countries are fast, like Denmark, Norway, and the Netherlands. They've already developed policy frameworks since the last 10 years already in order to deal with it. Other big emitters like Germany and also the connected countries, they are hanging, of course, behind because they are not directly at the solution already. So there is where the alignment between the high-level policies and the local regulations need to be implemented. Yeah, that's how the whole system needs to be driven forward.
Yeah, to me, this is one of the main challenges, actually. I think there's a lot of technological challenges. You need to look into details, of course, as for many things, the devil is in the details. But I think one of the main challenges currently is the policies and the legislation. So there are a few, let's say, guidelines and regulatory frameworks given by the EU, like the Net Zero Industry Act or the Carbon Contracts for Future. So there are, on a broader level, European level, there are guidelines, so to say, or regulatory frameworks, as mentioned. But as you already mentioned, the different countries are at a different pace and a different state. Like countries like Norway, Denmark, Netherlands pushing forward, they are already quite advanced. They are building the first projects. They have already some projects in place, like technologically scale projects in place, whereas other countries are kind of lacking behind. And I think this is one of the main challenges to really make this work, because particularly in Europe, you need to think about it on a European scale, because I think the big storage capacities are offshore, and you need to build a network cross-border. Agreements need to be in place. Now, things are picking up, pace is picking up, but things are, in my opinion, moving rather slowly on a
Yeah,
European level.
yeah. And well, from a German perspective, in other countries it might have been different already, but there's still the debate is in a certain circle. Yeah, it's experts, politicians, people who are thinking forward about it, and the companies affected. But in the wider public, CCS is probably not really a topic for many people. And so the public acceptance of all of these solutions is coming then into focus. Yeah. Like in all of the other things that you implement new somewhere, you need to make a big excavation for a pipeline. The public acceptance needs to be somehow achieved in order to make it work, or not to have it slowed down with lots of obstacles in the end. Um, so people might be concerned about leakages in these pipelines. They might be concerned about, oh, this is stopping the industry from going away from fossil fuels, so it's locking in a certain status. Some political parties, movements, they would even say, yeah, there's certain kinds of CO2 that should not be allowed to become part of the CCS story. Anything that is generated from fossil fuels or even coal, this is a big no-no for many people, that this CO2 is going into these solutions. And and sometimes people might just saying, well, not in my backyard. Yeah.
Yeah. So to me, it's a very challenging environment, and I think it's really about finding. There is no black and white. It's more about finding a balance between, you know, what needs to be done to make the European Union still sustainable in a way to keep the economic power, but also to balance it with socio-economical expectations, and to balance these kind of things, still push projects forwards that are reasonable, but bring people with it and generate an understanding why it is necessary and why it is important. I think this is the main challenge, to make this really work, to make it successful.
So to summarize all that and to achieve scale, as we mentioned before many times, it deals with managing the cost and having the right incentives to bring CCS or also CCU solutions on stream. It certainly goes in the beginning towards a public-private partnership and sharing risks on bringing things on track. It's about the policies in the countries and the policies to allow also cross-border transport of CO2 to reach storage sites from one country to another. And then in the end, exploring opportunities like linking it to other value chains, like, for example, blue hydrogen. Yeah, so also then enabling CCS by producing CO2 that goes into storage from the production of blue hydrogen, but the hydrogen itself also generates then value in other places.
Yeah, and to me, it's like, I mean, CCU definitely is a very good solution for parts of the problem, and I think this is where what I think is which really need to be understood. It's not a silver bullet, I would call it. I think we need to work on different areas, like optimizing processes, reducing the CO2 emissions in general. If you want to tackle this problem, we need to find many different solutions and many ways to reduce CO2. CCU definitely being one, CCU and CCS definitely being one solution, maybe interim, hopefully interim, but definitely an important one over the next years, decades to be implemented in different countries as a solution.
Yeah. And I mean, we have not really touched on what is actually still happening on with the CO2 certifications and things like this. The certificate trade that is supposed to run out sometime in the future. There's industries which are deemed to buy these certificates for the emissions already. They might not have the chance that anymore in the future, and they are already in a planning squeeze, so to say. They could forecast if nothing happens, if there's no other solution, we will probably use our license to operate in the late 2030s sometime. And that puts another pressure on going forward the solutions. Yeah, so going forward with making the right decisions in order to avoid that industry might decide that, you know, in this environment we can't sustain anymore. And this is still very much focus on EU at the moment. And we have not even touched on what the rest of the world is doing.
Yeah, exactly. There are many more topics we can and should discuss on this area, like as you just said, what's going to happen with the industry in Europe, but also what's going on internationally. Because I mean, CO2 does not stop at any borders, so we need to look into different areas, what's going on a global scale. But I think this is a little bit too much for this podcast. It's maybe something for another podcast. I think we can close it for today with this one. And I thank you for your time again, and it was a really nice discussion.
Yes, certainly a topic that will keep us busy for a foreseeable future.
Yes, exactly. And if you liked today's episode, or if you have any comments, feel free to post it on our comments below.
Thank
you
you
very much. With that, we thank you for dialing in today's episode.
I hope you enjoyed today's discussion. Maybe it gave you something to think about. Maybe you agree, you disagree. Let us know.
If you enjoyed today's episode, feel free to share it with your friends or colleagues, or tag us on social media.
You can find us on MND Consult, that is mnd-consult.com.
And if you have a topic you would like us to unpack, or a story you would like to share, feel free to reach out.
So take care and remember,
Shift happens.